Okay, so welcome again to this Campus Network Management as a Service meeting, InfoShare, the GÉANT project. I am Isabel Gandia. I work at CSUC, the Consortium for Services for the Universities in Catalonia, and also at the GÉANT 4.3 project on behalf of Rediris. And I am hosting this event today because we are working also in task 2 in Campus Network Management as a Service, and many NRENs around Europe, and not just Europe, but around the world, have started giving these services to their campus networks. Today we will have 5 presentations from NRENs and also from a university, the University of Michigan. I will share with you some slides just to show you the agenda. Okay, so can you see this presentation?
Yes.
And for the first comers, just let you know that this is the 3rd meeting. We have the 3rd InfoShare on CNaaS. We had one in 2020, we had one in 2021 where we focused on the tools to offer CNaaS. And today we are going to have the last meeting in this project to say what we learned during this journey with Campus Network Management as a Service services in the NRENs, also best practices and use cases, and this University of Michigan is going to be one of them. The agenda is like 3 with best practices and experiences, and then 2 use cases, but all of them are quite similar in a way. We are going to have Sikt from Norway, SUNET from Sweden, Funet from Finland, SURF from the Netherlands, and then the University of Michigan from the United States. After that, we will have questions and answers. And just to let you know, we will have 15 minutes for each one of the presenters. I'll jump in 2 minutes before these 15 minutes are done, just to let you know. And with this, I would like just to introduce Vidar Faltinsen from Sikt. He's going to explain what they have learned and their experiences in giving this type of services in the last 3 years. So, Vidar, the floor is yours.
Thank you. So I guess you can see my slide now.
Yes, perfectly. Thank you.
CNaaS in Norway. So I'm glad to be here. My name is Vidar Faltinsen. I am the product manager for the CNaaS service in Norway and for some other services we have. Let's see if I can. Yeah, you may have heard about the Norwegian NREN Uninet. We don't exist anymore. We are now called Sikt, the Norwegian Agency for Shared Services and in education and research in Norway. And we're owned by the Ministry of Education. We've actually merged with 2 other companies and have grown to about 370 people now. We used to be around 90 in Uninet. So we've had the CNaaS service in Norway for about 3 years now. We had the first pilot back in 2019. And as you know, this service is about building and operating campus networks for our customers or the customers that are interested in this. We currently have around 10 customers and we're growing. It seems to us it was perfect timing to introduce such a service. What we see and have seen the later years is that there is a general trend to outsource basic services in our community. And we also see that the work burden upon the local ICT departments at the universities is ever growing. And at least for the smaller institutions, they are really vulnerable in terms of know-how in networking. They may have just one guy just working part-time with the network. So it makes sense to build a central, strong team, and that we've done. And we'll keep growing this team as the service grows. So then we can scale and we can operate as rational as possible, and we automate where we can, and we definitely believe we are able to improve quality and improve uptime for the end users, and also important, improve security. So just 2 words on our business model. The way we do this is that we actually purchase the equipment ourselves. So we are the owner of the switches, routers, and Wi-Fi out on the campuses, and we maintain it. And for the customer, they have 2 options. They can either pay as a service a fixed yearly cost, or they can choose to pay the upfront cost with the initial investment and the initial cost of establishing the service, and then pay of course, lower yearly cost. Most customers prefer option A. Operating a service like CNaaS, it's a complex, obviously a complex service to operate. And we need to be flexible. So we've sort of, every customer is different. For some customers, we only operate the border router or the firewall that they have. For others, we operate the whole campus network with including the wireless. So we have this pick and choose model that we use when we discuss with the customers. Another factor, of course, at a large university, obviously it's unrealistic, totally unrealistic to replace the whole network in one go. But for smaller institutions, we've seen cases where they have all their equipment way beyond end of support. So definitely about time to replace the whole thing, and that's of course an ideal situation for us. But we've done cases where we initially operate the core of the network, and all the access switches, or most of them, are still operating, and then either the customer themselves still operate these switches, or we find another solution for that, and year by year we'll replace them. I think I'm getting someone's not muted, probably.
Done.
Yeah. I have to say we collaborate a lot with SUNET, and SUNET will talk afterwards. David would talk afterwards, and you'll see that there are a lot of similarities, which is great. One similarity, I guess, is on the architecture. We have the same thinking there. Typically, we can divide our customers so far in small and large, but common for them is that we build a redundant, in the large case, 10 gigabit core. And very important, we don't use any proprietary protocols. We use standard-based protocols. So we implement with eVPN, VXLAN, for instance, and other standard protocols. This is important for us because we don't want to lock into one particular vendor. So far, we've used Juniper for all the implementations we've done so far. And SUNET is using Arista. So, and in the future, we might use something else. So it's not locked down to one vendor. Just a picture from a build out we did, I think it was the summer 2020. So this was a fairly large installation where we actually did a new network. It took a while to implement this, 2,100 student dormitory rooms. In cases like this, of course, we don't do all the physical work ourselves, all the mounting of all the access, all the Wi-Fi and all the access, which is done by either by the customer, or the customer organizes that a third-party company does this, as is in this case. So just to explain the complexity of the service and some of the sort of major milestones we have to go through from the initial meeting with a potential customer to the services in full production. The first phase is we really don't want to drill too deep into the campus they have, so we're able to calculate an estimate of the price early in the process to see if this is at all interesting for the customer. If they're interested, we need to gather more detailed data. We need to clarify who should operate the close to net services like DHCP and not. We can do that, or they can do that. We need to clarify security parameters and do, of course, the design and actually know what we should order. And then we can calculate the final price and get an agreement, they sign a contract, and we can start for real. And then, of course, it's a lot of steps also. We need to do the IP address management. We need to populate based on the equipment we're getting in, the inventory database. We configure in an automated fashion the core of the network in the lab later on site. We do that ourselves. And we prepare the close to net services, establish firewall rules, and then it's the process of auto provisioning all the access switches, later the Wi-Fi. And then we might do this a bit different in every case, but this is more or less the way we do it. We migrate the users to the new networks. We build the new network in parallel to the existing, depending on the case though. And of course, we monitor the network and introduce the network to our NOC so that they actually start operating it. So 2 words about the service delivery model. We have a NOC, or service center, as we'll also call it, for all our services at Sikt. Which work daytime, and outside daytime we have on-call duty that will react on alarms. And then of course we have the second line CNaaS engineering teams that deals with more complex cases. But important here is that in the agreement with the customer needs to have a help desk or service desk, whatever, that their users, their staff and students contact. So no staff or students contact our NOC. Also, of course, since a part of the job of operating a network is a very physical thing, we need to actually mount the switches, replace the switches if they fail. We need to do the patching and so forth. So we have an agreement with the customer that they have some local people that can do that for us. Instructed by the NOC or instructed by our engineering team. To monitor the network, we use our own network monitoring tool, which is an open source tool called NAV, and we've developed this for a number of years, and it's a quite comprehensive tool. SUNET is also using it for monitoring campus networks in their CNaaS service, and it's used many places around the world. So this is a picture that I've shown before, I guess. And it illustrates how we collaborate, SUNET and Sikt, in this. Since we have a long tradition in Norway of developing a monitoring tool, we provide that into this. And SUNET has done a great job in implementing the automation engine, CNaaS NMS. I have to admit, we haven't gotten that far as we've we haven't fully implemented that yet, but that's definitely on our plan. But we are doing some homegrown automation for the time being. But this is what it will be. Important here also is that NAV, in the case where we don't implement .nx, particularly then, it's important to have a GUI for the customers so that they easily can change simple configurations like VLAN and port description on the access ports. So we have a tool for that in NAV, and just so that CNaaS NMS will do all the configuration, this is NAV will instruct CNaaS NMS, and CNaaS NMS will do the configuration.
2 minutes, Vidar.
Okay. The tool is like many other monitoring tools, is a single tenant. So we have one instance of this setup per customer, and with 10 customers and growing, it will be a lot of monitoring screens at the NOC. So that's why we've actually also implemented this tool Argus that presents an aggregated alarm console to the NOC. So Argus is a system that gives a single pane of glass in your NOC, and it's possible easily to integrate it with other monitoring tools like Sabix. We're working on that, and Nagios SUNET is working on that and integrated into this tool. So my last slide, lessons learned. Well, we've learned a lot through these 3 years, and still learning and developing the service as we go. And by no means we're finished with this. But we really find it essential that we have a good relation with the customers, with the technical staff at the customers. They need to work with us. We are there for them, to help them, and we need to create that atmosphere of collaboration in this. Still, we need a clear demarcation line, who is responsible for what. So that needs to be in the SLA with the customer. Also, in order to scale, as I mentioned, we find it's important to have the customer themselves or our NOC to do sort of day-to-day changes in the network. Also, we hope this reference architecture will sort of influence campus designs for all universities in Norway, also those that don't need this service from us, with the principle of being vendor independent. So plans ahead is to keep developing this, improving the processes, the tools, improving the automation aspect of it. We want to do more in terms of supporting IoT. I saw something SURF had done there, that we should look more into that. And also strengthening the integration with our security team, because we provide a lot of interesting data for the security team. So that's also a part we need to work more on. Sorry, I think I'm a bit over time, but I'm done now. Thanks.
Okay, thank you very much, Vidar. Thank you for your presentation. We will take questions at the end. So we will have the next speaker now, but please be with us for the questions and answers at the end of the InfoShare. Thank you very much, Vidar. Our next speakers are David Heath and Johan Marcusson from SUNET. They are also going to give us an overview of the work they have done in the last 3 years around campus network management.
Yes, thank you, Maria Isabel. Let me start to share. So it's displaying?
Yes.
Yeah, good. Yeah, so I'm David Heath, and I'm the service coordinator, and the lead architect and programmer, Johan Marcusson, with me today. We will go through this fairly quickly with more the differences on what we are doing in Sweden, but we are very jointly working together with Sikt in Norway. So we do pretty much the same things, but our main objective when we started this was to standardize the work and keep the expertise within the sector, because we have seen quite a lot of drain on the staff. Some people leave and then they have difficulty getting senior network engineers working. But we also needed to do more automation to get more easier replacement of equipment to make the changes more easily. We use a common reference network architecture, the same more or less as Sikt shown. And this was a joint work done with the SUNET network engineering team and the reference group from the bigger universities in Sweden, where we have everything redundant except the access ports themselves. And it's using the leaf spine architecture. This slide I think I've shown the last InfoShare as well, but we need to standardize the processes and help the campuses do the testing and having a mature model for upgrading firmware and keeping a reliable network, but also improving the security and have repeatable quality. And our procurement central has actually lowered the prices very much, but we don't actually sell on price itself, but we have shown time after time that we are competitive both on the equipment and giving them a 24/7 network operation center in the back to support them. And we do not lock the local staff or resources. We are doing this in parallel in dialogue with all the customers. And we also do a joint support organization where we share both the escalation. So the customer, they have their own staff, but they can escalate either through our NOC, or we can escalate both to the vendor or try to mitigate the problem. And some experiences that we have had, we started, I guess, 2017, 2018 with a scoping and a pre-study, and the procurement took a while, but it was finished in 2019, where we started the initial deployment at our first campus, which reached full production in 2020, which was the first year when we also signed one of the bigger universities in Sweden. And then last year we were an established service, and we closed the project and set it out to be a continual service going onward. So we are engaging with more and more customers as we go. And one of the things that we're doing is doing a new procurement for the SUNET core equipment, which could lead to a new vendor as well. Right now we are using Arista, but which we are very happy with. And other countries use different components as well. And we are vendor neutral from that perspective. Some of the differences between SUNET and Sikt is that we did our procurement central, where the customers can choose and buy their own equipment, and they can take the payment as they wish. The smaller sites, we can do the way that Sikt does it, where we pay and they have a monthly cost. But we do the service as a monthly service cost, not upfront or yearly. And the universities themselves finance their hardware usually. And we are not usually taking responsibility for data center or SAN integrations or the whole network. It's mostly on the distribution access and the core network. And since we got these huge discounts in our deal with Arista, we actually get quite a lot of equipment with 25 gigabit that could be used as well for distribution without any bigger costs. So that is used sometimes. And our main goal was to do the zero-touch provisioning with the SUNET NMS system that Johan will go into a bit after this, to do the provisioning. And we don't have any strict SLA, so we don't have any contracts for that. We focus more on collaboration and escalations. We don't have any penalties for bad service, but our service has been very stable. But we are very similar to, so Vidar's presentation is very similar to our work. And growing the service when we have a new contract, this is very similar, that we do an initial scope on contact and signing the contract together with them and planning the architecture. Right now we have some lead times on buying the equipment due to the situation on hardware components, so it could be 6+ months. So we do need a bit of planning to align that in the calendars for their customers. And then we usually do some basic functionality tests and integrate in parallel with their core and replace the core network. And then we do the handoff to the NOC for 24/7 operations, and we do follow-up meetings. So this is fairly similar to what Vidar presented as well. One thing that we try to do is very much have a community around our service. So we are trying to add at least 2 organizations in parallel continuously. That is roughly our capacity to do. We do biannual meetings together with Arista, where they go over the new things that are in the hardware and the options that we have. And we also have weekly meetings with all our clients that are, so they have like a user group together with us each week, where we alternate the agenda. One of the new things that we are adding as a service is firewall as a service, and also supporting remote offices that are smaller in scale. And we're also going to restart a reference group for future joint procurement. Another thing that we are looking at possibly is LTE or 5G at the campus, if that could be a sub-service together with Wi-Fi. But that is still in planning, but I wanted to mention it today. And we started out at a loss, not making any money. So we are growing the service, and now we're breaking even. So we are in a good stance of either lowering the cost or doing more things. Yeah, that was a brief presentation on where we are with the service, and Johan will take over on the network automation.
Yes, thank you. So my name is Johan. I've been presenting the CNaaS NMS software here a couple of times before, so I will just do a super short introduction for any new people, and then do a little bit of lessons learned also. But CNaaS NMS is the name of the automation software we developed for this service. And our goals with the software are basically these 3 things: that we want to do zero-touch provisioning of new switches. We want to automate the full configuration on the device, including VLANs, routing, port config, and so on. So you don't have to log into individual devices to configure. And we also want to automate the firmware upgrades. Next slide, please. Some of the design principles when developing the NMS software is that we want to support multi-vendor. And as David mentioned, we have Arista today, but we know we might have another vendor quite soon. So the software should support many different vendors. We want to have a licensing model that doesn't add any cost per device for the automation system. So you don't have any burden from adding lots of small devices in the campus. We want it to be open source and collaborate with other people if possible. And we want to have open APIs and plugins so you can integrate with, for example, a higher level orchestrator on top of this software, or plugging in different support systems for monitoring and inventory and so on. And these are some of the lessons learned in doing provisioning of new switches, or the zero-touch provisioning. So first, someone has to be on site and physically install the devices. And at that point, we also want to note what serial number is installed in which room and which position in the rack, so you can later figure out where the devices are located. The next step is in the NMS system, where we basically get a list of all the serial numbers or MAC address that we have discovered in the network. All the switches boot up using DHCP, so we populate a list, and then you select in this list which serial number you want to provision, and you give that device a host name. And at this point, we also learned that we should actually upgrade the firmware before we start any configuring of the devices, because sometimes the configuration can be dependent on the software version, and it's not always sure if you get a certain software release when you order new products. So it's best to always start by upgrading the firmware, and we do this in the process automatically. And then once we have provisioned the switch in the NMS, it's going to be added to our inventory system automatically. We run an in-house inventory system developed at Norway and SUNET called Network Inventory. But then we have like a manual step where when we actually decide when the switches should go into production. So we add the switches to the inventory system first, but they're in a state like provisioning state. And then once the customer is ready with everything, then we mark the device in the inventory as in service or in production.
2 minutes, Johan.
And once we mark it as in service, then we add it to the monitoring system. And again, we're using NAV developed at Sikt. So this is like an important distinction, that we don't add devices into NAV, so they do send alarms and stuff immediately. So there could be like several weeks between we provision a new switch and the time when it actually goes into production. Maybe David wants to jump back in for the ending of the...
Okay, thank you, Johan. This is, as Johan mentioned, all open source. So we would like other people to contribute and use the things that we are providing for everyone, because once we reach momentum, we can do joint engineering, we can share experiences and do different subcomponents that are in use for doing a full orchestration. I know that SURF is coming up with some good examples, and Sikt has done the development of Argus that we are using as well, together with NAV. So we are importing like alerts from Nagios and other things as well. So I think building this ecosystem together is the future. So these are some of the references that we have at SUNET, at least. So I hope that you take the time to take a look, and feel free to contact either me or Johan to get some more information about it.
Okay.
And we think save the questions for later, right?
Yes. Sorry, David, because I jumped in. Thank you very much for the presentation, both of you. Very interesting. And we will take the questions at the end, as before. The next speaker is Asko Hakala from Funet, who is also offering campus network management services from long ago. Asko.
So how you see my screen now?
Yes, perfectly. Thank you.
Good. So my name is Asko Hakala. I work in a company called CSC, Center for Scientific Computing, and one of the tasks CSC is having is running a Finnish university network, Funet, and part of the Funet services is this campus service. So the background is that we started already 2012 a service called Funet router service, which means that we had CPE routers for Funet network connections to our customers, and we still have 9 customers in that one, having 21 routers, and they are all Juniper MX models. And one part of what we are doing now with this new service, we are taking in new customers, but we are also migrating these old customers to this new service, and we are having there, like last week we got one of those customers ordering this new service, so we will get rid of one old customer and get one new customer at the same time, and a couple of new routers and a couple of old routers are going away. So, and this new service, it's launched in 2019, and it's rather similar, but we are now going deeper into the customer network, so we can also provide switching for aggregation or access layers. And here we are having 14 customers, and we have 25 Juniper routers and 16 Juniper switches and 37 Huawei S-series switches for those lower parts of the network. And as a resources, we are having a 3-person virtual team, which is not very much, especially because we are working part-time with this. We are also working with Funet core network. And for this Juniper devices, we have this Ansible automation, so all the configuration is made using Ansible, and these templates we are using, they have been evolved from the templates we used to build our new Funet 2020 core network. So we had could reuse some work we have done earlier. And for use cases, one use case which is the most common one is this CPE type connection. So we can have uplink up to 100 gig now, and it's usually so that it's not just the internet connections to Funet, but there are layer 3 VPNs and layer 2 VPNs, and they often can go, for example, to CSC data centers if there are something like some sensitive data things or something like that. And most of the time we have these redundant connections, but for some smaller cultural or research institutions that have only single Funet connection, we maybe have just one switch there. And this is really the use case what is most in demand. So we have 16 customers of there, as we have a little bit over 20 totally. And the second, which is very big in terms of design and planning and also time of work it takes, is to having this uses campus core or campus interconnection service. So there are customer core from edge routers and often down to the aggregation switches also, or connecting customers' campuses that are different parts of Finland. So we are either using dedicated links for this connection inside this core, or we are using layer 2 or layer 3 VPNs over Funet core. Like often cases that we have layer 2 VPNs over Funet core, and then we are running layer 3 VPNs and layer 2 VPNs or whatever between those campus routers themselves. So, and this kind of service we have for 6 customers. And also what we usually think as a campus service, it's this whole switch fabric down to access switches, but we have only one case of these, and it was for a customer who had a new campus site and they had to set up a network very quickly, and so we provided it, but all the services for this network are coming from their main campus. So, but we haven't done very many of these, but some. And the experience what we are having is so that it's maybe a little bit misleading calling this campus service because it's just routers and switches. We are not providing any access points or DHCP or TACACs or firewalls or anything like those. It's just switching and routing. But it's also so that like the CPE is most commonly required feature. It's often that the customer either has skills to do those extra services or they can buy it from some commercial provider. But integrating these things to Funet networks and maybe Funet CSC data centers and so on, then we can offer some advantage in that, and it's also what the people we are working with this service now are best at doing, because we have this router background usually. And also one thing is that we have noticed that every customer case is different. We don't have that many devices, it's about 100, but we have over 20 different networks and they are all different, and so it's quite a lot of work and also a lot of expertise, because it's not just implementing those changes, but it's very much also the consultation. When customer is doing any bigger network changes, they often ask our opinion, and also for cases where it's not part of this our service, but they are planning to, let's say, having a new firewall setup or something like that, they are usually asking for our opinion also, even if it's not our responsibility. And because customers are having those other providers also, so there is a lot of coordination with customers and maybe their third parties or fourth parties and so on. So there is quite a lot of negotiations also when there are any changes. And one thing is that it makes a little bit difficult to estimate the workload we are needing, because if many customers are having a big changes at the same time, it can be quite busy time for us, and sometimes it's so that customers contact us in a planning phase, then it takes some times before the actual implementation, and so it's quiet for a long time, and then it's a quite big hurry to do actual changes. And about the equipment we are using, because these were mainly, we have been using the contracts that are used for other things, like we have this service provider level routers which were used also for a Funet core network. So the very good thing is with them is that they have a very rich feature set, and also there are synergies, like we could do things what we had early this year with one customer who had wanted to add a new location for a network for very quickly, and there was this long lead times for new equipment. So we made it so that initially we provided this functionality to in our core network, and when the equipment arrived, we move it to a campus network. So we could serve a customer even before we have equipment in place. But the problem is that they are pricey, so it means that usually it can be so that in some cases we don't have as many devices that we would like to. Like in this earlier use cases, there is this picture on the right about this core network, and there are this couple of routers here that connect from one campus to our to the aggregation switches, because it would have been too pricey to have a router pair in every campus. So we do something like that sometimes, which would be better if we had some cheaper equipment and could do the same. So we could have a little bit more optimal design for devices. And also one problem with those routers is that they have a rather small port density, which means that even for quite small networks we need this separate aggregation layer. And then we have this low-level switches that were bought for initially for our own office network without much thinking about this automation features and so on. And the good part for them is that they are cheap. but the bad thing is that they have this model-specific feature set. So if a customer demands are changing and we can't maybe use the same equipment that was initially provided, and because we usually provide this with the initial 5-year lease time, it can be very bad if you have to change equipment in the middle of things. So that's not good. And very big showstopper is that they don't have this full commit configuration change, so they are very difficult to automate. So using them doesn't scale very well. So what we are planning to do next is that we are looking for a new equipment that would be more optimized for these campus purposes. So something rather cheap one-use switches with routing capabilities. And we are thinking that we should have two roles there, like IP MPLS router and layer 2 switch. And this layer 2 switch, it can be combined into this IP MPLS router if a network is small enough. And we will have IP fabric and layer 2 overlay network between the sites when we are talking about this interconnection or core network type services. And this layer 3 routers, they should have this MPLS VPN capabilities, and always for the devices that are facing the Funet core network, they should be these layer 2 routers. So we can grow them if a customer needs are changing. And because in campus networks usually you have to also have layer 2 networks spread between the different campus sites, it has to have this layer 2 with the EVPN capabilities. And if there are customers' own access switches that are connecting to this network, then there should be LACP towards them so that we can provide redundant access for them as well. And a big part is this automation support, so that devices with the different port setups and roles should support same APIs or netcon for our automation tools, so that we can use the same automation features we develop for all the devices we are having. And also this full commit configuration change is very important for this automation. And also we want to have this confirm commit option so that it automatically rolls back if there is something going wrong, because Finland is rather big country and this campus networks, they are geographically very far away from each other. So if something goes wrong, we don't want to lose access to a device.
2 minutes, Asko.
Okay, yeah, I think I'm pretty much done now. So thanks. I think that was what I have in.
Okay, thank you very much, Asko. We will keep the questions until the end if you don't mind it too, but thank you for keeping it short. Our next speaker, I see he's already sharing, is Vidar Boers from SURF, who is going to speak about SURF wired, SURF wireless, and the developments on campus network management.
Yes, thank you, Maria. Yeah, so give you an update from the SURF perspective of campus services and all the stuff that we do. My name is Vidar Boers. I work at the networking department for the past 6 years, more or less from a software point of view. So I've been busy working on the automation and orchestration suite, and rather recently we actually started implementing and using the CNaaS software that SUNET and Uninet also use. So I'm going to take you through a short background short background story about our CNaaS, our portfolio. Hang on, let me see. There we go, it's moving along. So SURF started with a campus service in 2016. We did have initial slow uptake, but as of 2022, we have around about 12 customers in the Netherlands that are taking making use of the SURF Wireless product. SURF Wireless is a product where we would where we go to the institutions and where we basically deploy all the access points, and then they can have that as a service from SURF. And then moving on from that, we're starting to see a lot more campus services coming, or services that are very closely related to the campus coming online. So last year we had the launch of SURF Firewall, which is basically you can buy a firewall slice, and we will you can use that to protect your campus or protect your internet connectivity. At the end of this year, we're expecting our network functions virtualization platform to come online, which will start hosting Edge VPN, potentially a virtual router as a service, virtual firewalls, and obviously we're also working, we also have the Edge Roam service and the IoT Roam service, which could potentially move towards a radius as a service type of product. Yeah, and along with that, we also see lots of, especially smaller institutions in the Netherlands, starting to offload all their on-premise services into services that are running in public clouds. So DHCP, DNS, all that type of stuff is no longer running in their own data center, but is running in the cloud. And yeah, what you see, obviously, has already been mentioned. It's the same trend in the Netherlands as well. More and more needs to integrate with clouds, and a brain drain and a transformation towards management organizations. And then with this in mind, in 2021, a number of institutions came to us, and they asked us to develop a integrated campus solution, because they were already going to take our wireless product, but they also said, well, you have this nice wireless product, why don't you also develop a wired, so like a wired campus solution. And this is something that we've been working on since last summer, to start really hashing it out. What would that product look like, and how can we create that at SURF? And well, what we've sort of come up with is the SURF Campus product portfolio. A SURF Campus would be an umbrella product portfolio which will enable end-to-end connectivity between institutions, clouds, data centers, and encompass a variety of different products, from hardware, software to also licensing, which is something that we also do in different areas. And at the moment, we sort of have the hunch, and obviously SUNET and Sikt also see that if a campus will, or an institution will subscribe to a certain campus product, it's more likely than not they're probably also going to start using some other campus services. And yeah, we really want to make sure that's all integrated, so that we can sort of unlock the potential of what SURF can do, right? So what's next? We've had progress on two fronts during the past few months. Obviously, we've started thinking about the campus as a service product portfolio, but the more immediate issue is the developing SURF Wired, the wired counterpart of SURF Wireless, as we have to start deploying quite soon, actually, on that campus. So what is SURF Wired? SURF Wired's inspired by the SUNET model, and it's leveraging the software that's built, and we're sort of starting to tailor it towards how we would like to deploy it in at SURF. And well, actually at the end of this month, the first deployment was planned, but it's sort of shifting, and more likely to be towards the late summer, because the building that we want to install into is not quite finished yet. And well, what is SURF Wired, right? So it's the wired component of Campus as a service, and it's obviously born from the CNaaS NMS project, and adapted towards our use case and operational model. At SURF, we have an external outsourced network operating center, and we have to sort of start thinking about how we can integrate with this entity, So we have certain requirements with tooling and software that we can't really use, that we can't operationally use the same type of software that SUNET and Sikt use. But the core of the service is still the CNaaS NMS. Project is still in pilot phase, and we've also chosen to use Juniper hardware because SURF is also running Juniper on our core. So we sort of started to try to leverage the same contracts and also the same experience with hardware and relations with our vendors, just so that we could kickstart the project. So the building that we're going to deploy is a location called Mind Labs. It's in Tilburg. It's quite a large city in the Netherlands. It's greenfield installation, but it's not trivial because there's 3 institutions and even more other startups that are in that building, and they all have a mixed and matched set of requirements, which basically has been quite a challenge to align due to the fact that they have all various ways of authenticating users on the network, different ways of deploying their network, and you need to make sure that everything is sort of aligned before it starts working. They will be making use of SURF Wireless and SURF Wired, and as I mentioned before, we also have EduRoam and IoT Roam. That will be started. That we will also start leveraging that to make sure that everybody can authenticate correctly to the network and that we can handle devices as well. Obviously what we'll also be doing is we've joined the discussions with SUNET and Sikt, and we've started contributing to the CNaaS NMS project, and I guess in the future we will also continue to do that and really invest, because I think we share the same ambition that the more people that get involved in this project, the better it will become, and it's also a good alternative to buying licensed products from vendors. So this is a brief overview of the networks that we are going to support. Quite a variety actually. And the pilot that we are running will actually have to support all of these network types. Basically, there is the backhauling towards the home institution type, which is this one, the second one, the yellow one, and we also have various models in between where we will either backhaul through layer 3 towards the home institution, backhaul through layer 2. Or go straight towards the internet through a firewall. So challenges that we've had so far. The hardware lead time is extremely long at this point in time. For basic EX series switches, for some models we've been seeing lead times which is longer than 12 months. So we've had to go and buy refurbished and repurposed hardware to get the pilot online on time, which is actually quite a challenge. Well, radius is also being a very difficult challenge to sort of get online and make sure it works. It's basically an integration challenge more or less than if the technology is not able to do it. Every different institution has their own way of authenticating clients, and we've had to make sure that we sort of figure out which attributes we need to check, the VLAN mappings, to make sure that everybody sort of is safe and secure in their correct network segment. And this is not trivial because it's more complex than even the institutions thought themselves that it would be. Because of all the various requirements, we've had to concentrate on all the different architectures that I showed in the previous slide. And this makes it actually quite difficult because from day one, you have to support everything instead of choosing on like the basic variant where you just do a firewall and internet and then you go from there. Now we have to support more or less every scenario. And well, there's all sorts of other stuff that you can also think about, where I guess the definition of as a service is also something that's very contentious, because where is the cutoff between what the customer does and what SURF will do? And it's a discussion item that we still that's ongoing, and we need to figure out. So how does this fit into our software architecture? This is a brief overview of our software architecture at the networking department at SURF. I guess many of you may have seen this before, but we have our own homegrown orchestrator, which has a number of sources of truth, which you see on the right-hand side of the screen, and it will provision towards a number of different technology domains. And what we foresee, and that's something that we're probably going to start work on from next year onwards, is the fact that we will create a wired controller that will implement and control the campuses beneath our homegrown orchestrator. And the reason we're going down this route is because we already have quite a large number of institutions who are keen on following the progress that we are making, and may or may not, but probably may be very interested in taking this service on in the near future. So we need to be ready to be future-proof for that. So development, SURF-wide development and deployment philosophy, rinse and repeat. That's probably one of the main things that we are going to try and focus on. Make it repeatable and predictable, make it reliable, so we can have a very easy operational cycle, so to speak. We also want to start experimenting with turning off and on certain parts of the software, like DHCP servers or firewall integration, or you can pick and choose the way you connect towards your own campus or towards a cloud.
2 minutes, Peter.
Yeah, almost done. Thank you. And yeah, obviously integrate very heavily with our own SURFnet 8 core, where we can backhaul traffic towards all the different cloud providers, or our firewall service, or NFV, etc. Yeah, just to make the integration seamless. And yeah, contribute to the open source project, build a community, and make sure the knowledge remains inside the NREN community, so the wider NREN community, as well as with the institutions in the Netherlands. So I guess final slide. What are things that we want to contribute to, and sort of what we see that we need in the future is as a number of these things. We're probably going to contribute quite a few things, or we would like to contribute quite a few things to the CNaaS software, and make it flexible, and try to increase the way how we can use it inside our own infrastructure. We also would like to contribute back to some parameterized Ansible and Terraform scripts, so we can deploy the CNaaS NMS on our own infrastructure, and make sure that we can create new DHCP pools and all that type of stuff. So that's all automated. Route maps, access lists, and eventually we would also like to integrate it with our own orchestrator. And I guess this is a shameless plug for our open source software. You can find that on that link. This is something that we've open sourced and is the core of our own homegrown network orchestrator that we use to automate all of our services on our core network. So that's a brief rundown. Next slide is this, but we save that to the end. So I guess that's me. Thank you.
Yes, thank you very much, Peter. Thank you for your presentation. This was the first presentation today. Our last speakers are going to be James Ostrander and Nick Grundler from the University of Michigan, who are going to give us their overview of their campus, because in this case it's not an NREN, it's a university that's dealing with many campuses, and we will have the networking and the software views of the service.
Hey, thank you. So just real quick, Is my mic working okay? Can you hear my screen?
Yes, yes.
All right, perfect. Thank you. All right, so my name is Nick Grundler. I'm a network engineer from the University of Michigan, and we're just going to start with a brief overview here of the University of Michigan network, just to give you guys some context. So this is just a very high-level diagram of our core/backbone network, and so we sort of these 6 boxes here are Juniper MX960 routers, and we kind of manage and run it's kind of a bit of a cross between a large service provider network and an enterprise. So we're kind of sandwiched in the middle there. And so we kind of run this backbone, and then other organizations within our campus connect at this layer, like our hospital system and different colleges within the broader university. And we have some other satellite campuses as well that connect at this layer. But principally, we have, something like 200+ different buildings on our campus network that we have kind of split into, an aphorism we have here locally is that we have kind of 19 colleges that share just one common football team. And that's just a way of kind of describing the unique organization of the University of Michigan from a funding perspective. And that sort of comes into play for how we run the network, in that each of the individual schools and colleges have their own funding, and then they come to us to help them provide network services. So we're kind of, when I say we kind of sit between a service provider and enterprise, that's sort of what I'm referring to, in that we don't have complete control over this network, so to speak. It's more of a stewardship role. And so from an automation perspective, this means sort of defining the problem is kind of the most interesting and difficult part of this whole process, because everyone on our campus is a little bit different. And we have configuration changes coming into the network from a lot of different directions. We have some units still have direct CLI access to their closet switches. We run a tool called DCT, or the device configuration tool, where campus administrators can log in and just configure ports on their switches and things like that. And so part of this, a big part of this process is kind of, I don't know what the right word to say here is, bringing some kind of sanity or structure or organization to this very, very complex and heterogeneous network. So one of the big things that we've been working on right now is creating software models to organize the different services that we provide to our campus. And this is, I think, a very powerful tool for that we're finding that this is a very powerful tool to sort of abstract some of our complexity. And it's been a big effort that's sort of spanning our engineering, operations, and software teams. And the other piece of context here is that this is our current network that's based on Juniper MX960s, but we're in the process of building a greenfield Cisco EVP and VXLAN network that we're hoping to automate from the ground up. But just to go into a little bit about our current process and some of the things that we're hoping to solve with this new automated solution is, I think we're probably not too dissimilar from a lot of the other networks out there, in that because we've grown so heterogeneously that our network, the documentation for our network isn't great. We're very heavily reliant on institutional knowledge, and this is something that makes automating all this extremely challenging. Just because of the way we've grown so organically, a very common situation is that we may not understand why a particular configuration in one of our 200+ buildings exists, and who wanted it there, if it was still needed or anything like that. And so this kind of has led us into a situation where we're nervous to change things, and configurations sort of drift and become ossified over time, which is why we're really looking to automation to solve some of these things. So moving on here, one of the so I talked a little bit about software models, and the language that we're using for this is called, or to define these models is called Yang. And the reason I think, one of the main reasons we really like this is because these software models can sort of operate as a contract between the software and the actual hardware of the device, right? And so a lot of our existing automation is simple Perl scripts and things like that that connect to devices over SSH, and we do a lot of just expect-based automation today. And these Yang models just give us a way to orient all of our software around a common data model effectively, which makes things a lot more maintainable and understandable. And just in case you've never seen Yang before, this is just a quick example where you can define sort of schemas using some very simple, what do you call it, a domain-specific language, and then you can, we use XML to, we use XML encoding to talk between the different software that is used in our model. And so we settled on a Cisco product called NSO. And one of the big factors for this was that our network is very multi-vendor. So we have both Cisco, Juniper, and Arista in the route switch part of the network. We also we have a lot of security devices and firewalls and Wi-Fi, but they're sort of not in scope for our current automation. And so one of the things that we really liked about NSO was it provides a centralized database that enables sort of a network-wide transactions for all of our equipment. And so even though some of our Cisco routers and stuff don't provide transactional APIs, we were able to get this from NSO. And so we could provide kind of a similar level of, it gives us an API for our Cisco and Juniper devices that is and so, excuse me, this allows us to have a Am I coming through okay? Hello?
You're cutting out a little bit.
Oh, I'm sorry. I think I might be having some network troubles here at my house. Let me see if I can move forward here a little bit.
Yeah, if you need me to pick up and take the rest.
All right, if I cut out again, James, just jump in here and feel free to take over my screen share. I'm sorry about this. So if we can just talk about a little bit how NSO works. What we're doing inside NSO is we're creating sort of these service models that we use to map onto devices. And the way this works is we can use the Yang model to kind of orient in between a service model and the device model. So the intention for this slide here is to kind of highlight what a service model on the left, and then how that gets expressed to the device model on the right. So one of the main services that we're designing for our campus here, we just call it the distribution service. And what this does is it sort of manages the individual LANs within the University of Michigan campus. So we might have 200 plus instances of what we call these distribution zones. And then within each zone, that really sort of maps together the distribution routers to the individual closet switches in our campuses. And then on those individual switches, one of the primary one of the primary things the distribution service does is it allows campus network administrators to configure ports and VLANs on these switches themselves. And one of the main reasons we really liked NSO for this reason is because, is because it handles the translation to the device native syntax. And it does this by abstracting things into its own kind of data model where it can represent the device configuration in sort of structured XML, which means when we're parsing configurations and generating this data, we're no longer having to sort of just parse raw text directly from a device configuration. It allows us to work with these structured models, which means we can write software that's a lot more reliable. And this is just sort of a very high level example of what the distribution service looks like. And we have, I think I said we have about 200 plus buildings on campus, and we organize those into roughly 180 different distribution zones. And so each one of these zone instances that we can model represents, like I said, the distribution router and the closet switches within each individual building. But this also ties together our IPAM service in that this is at the layer where we can create individual networks and VLANs and prefixes for our customers and associate them within those different distribution zones, and then use NSO to actually push that config directly to the network device itself. And here, I think I'll just hand it over to James. Hopefully you can still hear me, where he can talk a little bit about some of the software we're building on top of this distribution service.
Hey there, no worries. We heard all of that, or at least I did.
Oh, good.
My name is James Ostrander. I'm a software engineer. So Nick is more on the network side and I'm more on the software side. So as Nick mentioned earlier, we have this tool called DCT, which stands for Device Configuration Tool. It's an 8,000 line Perl script. It's pretty hard to manage. It speaks to all of these different types of models and models of devices. It has separate code paths for all of them, which is kind of difficult to manage and sort of messy and error prone. Next slide, please. So it's expect-based, meaning it's sending commands over SSH, and it retrieves the data over SNMP. So there's kind of it's a little bit, it's not apples to apples in terms of the input and the output. You send messages one way and you retrieve output another way. And as I said before, a lot of branching and conditionals. So it just makes for sort of messy code, and it's generally somewhat frustrating to work with, as is expressed in this actual line of source code that you see at the bottom. Next slide, please.
I'm afraid there are 2 minutes left, James. But...
No problem. Yep, I can get through it.
Thank you.
So here is a look at the NSO architecture on the left. And at the top of that graph, you can see that you have REST, netconf, Java, Python, etc. between the applications and the rest of the NSO stack. So those are the northbound interfaces that we can speak to the outside world with from NSO. We selected netconf because that is sort of the native language of Yang and of NSO. Next slide, please. So here's another look. Here's a look at our new graph with NSO in the place of DCT. You can see on the left between NSO and NetDash, which is our new network dashboard. You have netconf speaking between them, both forward and back. And under NSO, you have many different device types. It can speak to these through a concept called a NED, or network element driver. So NSO contains the logic to push network device configurations to all of these different types without the program NetDash, or DCT as it was, needing to know how to talk to all of them at all. So that pretty much simplifies the code that we have to write drastically. This tool we wrote in Django. It's a Python web framework. So far fewer code paths, much simpler code, nice greenfield software to work with. Next slide, please. One of the tools in our network dashboard called NetDash that we have is called SwitchConf. That's really the DCT replacement. You can put many different tools in NetDash, and one of them is called SwitchConf. The purpose of this is to let units manage their switches and the ports on them. So here you can look up by end user device, MAC or IP address, or you can just look up a switch directly. Next slide, please. After you look up your switch, here's a look at what you can see. You have a table with all of the different ports on it. You select some ports. You can then click edit, and it will let you batch change their different fields, which are pushed as configurations. So that can be VLAN, speed, duplex, admin status, VoIP. This could potentially be expanded more in the future. Next slide, please. And when you push those configurations, here's how it looks in XML. You have an envelope expressing which NSO action it's going to call. This NSO action is code written inside of NSO by Nick and Amy. And the configuration payload is in the center there. Within that configuration payload, you can see that we're pushing a description in a VLAN. So those are the changes that we're making. Those get sent to NSO, and NSO then translates those to CLI commands, or it could potentially be just directly talking via netconf to the switches. It really just depends on the switch. The network element driver decides. And once everything is good, the NSO will give the thumbs up back to the application and knows that everything worked out, and we can tell the user that everything is good and their change was successful. And that is all. And we have some learning resources provided by your organization on the right.
Okay, thank you.
A little bit about APIs, netconf, a lot of things to be covered.
Thank you. Thank you very much, James and Nick. Thank you for the presentation. Thanks all the speakers for the interesting presentations. Are there any questions from the audience? If there are questions, please raise your hand in the chat or write them down. Raise your hand in the participant screen, or just write them in the chat and I can read them loud, or I can give you just the access to the speakers. Anyone wishing to ask anything from the audience?
I have a question.
Okay, Peter, go ahead.
Thank you. So I was curious to know from the University of Michigan, how are you guys handling the licensing costs of NSO? Because I saw you guys had 4,000 or something devices. Is that something that is prohibitive, or do you have like a special licensing model that you don't have to pay for every device, or what's going on there?
Yeah, so I think, stretching my memory back to a couple of years ago when we were doing all of our contracting with Cisco, the bulk of our scale comes from our closet switches. So the way I recall it breaking down is they had, at the NSO BU within Cisco had like a large device and a small device model. And, you know, we just have a few large devices for the core network, and the rest of our other devices are small devices, but there is a per device licensing model. And so it you know, our director worked out something with Cisco. I don't know all the details.
Yeah,
I can definitely put you in contact with him if you'd like to know a little bit more about that process. But there's definitely a node-based licensing model that we had to work with Cisco on.
Yeah. Okay. Thank you.
In fact, I see the chat, and there is also a question from Nicholas saying, any hint about Cisco NSO price tag?
Wheelbarrows full of money, I think, is what how we typically put it around here. I do full disclosure, I'm just a simple network engineer, so I don't have all the financial details, but I would, if anyone wants to know more, I'd be happy to put you in touch with my leadership here.
Okay, thank you. So maybe in case anyone is interested, they can contact Nick. Are there any other questions from the audience? We have heard a lot about automation, about orchestration and virtualization, and the campus network management as a service are clear examples of this, of the usage of these things. I see that Max is also asking a question. We had the issue with NSO that all MX junipers are categorized as large, even if it's MX. Yes,
that was
Max.
more of a remark.
Okay. So even if they are not very big, they are categorized as large in NSO. Well, I would like to ask you about this this integration with clouds that was mentioned in one of the talks. I think it was in SURF with Peter. Is this something that your users are asking you to offer, or is this something that you are preparing to offer because you know the cloud's coming?
It is something that we are actively working on at this point in time with our core network. So basically what we will do, we will integrate seamlessly with our own service and then Azure Express Route or Direct Connect, but it'll stop at sort of like the end at our CPE device. And then from then on, the customer needs to do their own thing. But we sort of foresee like the next step that we would even continue on with that same service and just extend it on towards the campus or perhaps towards their own data center, because that's obviously also a use case which then comes very close by. So yeah.
Thank you. There is a question in the chat. I have just an observation. SURF seems to have started with providing wireless without touching the fixed campus network at first, while Sikt, SUNET and Funet have gone the other way around, starting with access router and working their way towards the access point. Is this more or less correct? I would say yes. And I see that there are some answers already in the chat saying correct from Vidar, from Sikt. And Johan is saying SUNET does Wi-Fi at the same time as wired, but that solution is using the vendor's own management tools and not our own open source stuff. Is there anything you would like to add to this?
I guess from SURF point of view, I would say it's correct. Yep.
Okay. Thank you. Okay. Yes. Sorry.
I could comment on that, and because discussion we had is, and I guess this would be a question for Peter then, because we had this discussion: can we operate the wireless without having any control over the wired network? I mean, if the wired is rotten, your Wi-Fi service will seem no good, even though it's professionally run.
So your question is, I guess, what guarantees do we give?
Yeah,
or is that, yeah. So I'm not 100% sure what guarantees we do give, because it's not my area of expertise. But there are some service level specifications, and it is monitored. So we do monitor performance metrics, and I guess if we see, we can sort of pinpoint where the problem is, I guess. And then if it's wireless, then obviously we'll fix. But otherwise, if it's wired, then yeah, it's the customer or their own integrator who needs to get along. But I guess the institutions, they found that difficult as well. It's like, well, you do wireless, why don't you do wired as well? And that's sort of like that's where the use case came, or the question from the institution was like, well, please also solve this wired issue for us as well.
Yeah, the use cases are also relevant, or what your customers are asking you, of course.
And regarding of those cloud services in Funet's part, it's so that CSC is providing a lot of cloud services. So one of our advantages is that we have a very good possibilities to integrate those to our campus service. And of course, we are doing similar integration also for Funet members who are not having a campus service, but it's more control for us if there is this campus service as well.
Okay, thank you. Thank you all for your answers and for your presentations. We're leading to the end. Are there any other questions that we can quickly solve? If not, let me share again my screen just to like a wrap up. Oops. Okay, well, thank you all the participants and all the speakers for their interesting presentations and for being here today. And I added to the end of this info share just a few, well, just a few events that are coming in the next 2 months. The 16th SIGNOC meeting is next week. The 3rd European Personnel Users Workshop is in 3 weeks, in case you are interested. There's the TNC in June, and also the Management and Monitoring on Time and Frequency Services in June. I also added the links that the University of Michigan also presented, because we have heard about many tools and then models and software tools, and one may get lost. So if you want to know more about these tools, we have all these links here. I will put this slide in the event page so that you can access these units on the Network Automation Academy, and you can also suggest new units in case there's anything that you would like to see and is not there. With that, I would like to thank you all for being here, and that's it. That's all for today. Thank you very much for being here, and see you in the next events.
Thank you.
Thank you. The presentations will be in the event page between today and tomorrow.
Thank you. Bye.
Thank you.
Bye.
Mm.